Okay, so this is the paper 1 non-calculated paper from May 2018, which we did in class on Tuesday. So we can do the first 6 and then skip to question 8. Question 1. Circle the best approximate value for the following calculation. So although you got a choice, do the maths. I'm going to round the top one to 600 and then this to 38 down to 12. And I'm doing that, so we're rounding them. Yeah, so I'm doing that because that's going to round up to 50 then. So I got 600 divided by 50. I can divide both by 10, so I can knock off a naught. 60 divided by 5 is 12. So that's my approximation. A number is increased by 4% of its value. This is done 7 times, each time increasing the previous value by 4%. So this is compound increase. We practiced this for the numeracy paper. If it's been increased by 4%, then you end up at 104% of the original amount. And every time you do that, you raise to the power. So if I'm doing it twice, it would be 104% times 104%, 3 times 104 times 104 times 104, and so on. So I'm looking for one of the ones to the power of 7, and 104% written as a decimal would be 1.04. So I'm looking for 1.04 times 10 to the 7. Calculate 4/5 divided by a quarter. Now when you divide by a fraction, if you think about if you're dividing, we did a question like this in the previous paper we went through. If I am doing 1 divided by a half, that means that I'm dividing 1. How many halves are there in 1? And there are 2 halves in 1. So if you're doing 1 divided by a half, you end up with the answer 2. So you end up doubling them. If you're dividing by a quarter, if I want to see how many quarters there are in a whole, there would be 4. So 1 divided by a quarter is 4. You'd end up multiplying by 4. So what you've got here is 4/5 times 4 over 1. When you divide, you multiply by the reciprocal. You turn the divisor upside down. So that's going to be 16 over 5. 4 times 4 is 16. 5 times 1 is 5. And then what you've got here is you haven't got 16 over 5, but 3 wholes are 15 15ths. 15 fifths. 1/5, 1 whole is 5/5, 2 wholes 10/5, 3 wholes 15/5, plus a fifth is 16 over 5. So that is the correct answer. 1 mark for each of those. Question 2. Venn diagrams. "30 rugby supporters travel to Cardiff on a coach. They decide to investigate how many of them can sing one or both of the songs Hen Wlad Fy Nhadau and Bread of Heaven. 12 say they can sing both, 18 say they can sing Bread of Heaven, 5 say they cannot sing either of the songs. So complete the Venn diagram below to show this information. The universal set E, which is the box, contains all of the 30 supporters. So the numbers that we drop in are going to have to add up to 30. 12 say they can sing both. So in this question, it's a relatively straightforward one because they're telling us the overlap. Sometimes we've got to work out what that overlap is, which is a bit trickier. 5 say they cannot sing either. So that's going to go outside the circles. And 18 say they can sing Bread of Heaven. So that full circle has to represent 18 people. 12 of those can sing both, which means 6 must only be able to sing Bread of Heaven. So at the moment in that Venn diagram, I've got 23 individuals, there are 30, so the missing gap must be 7. And then that will complete the Venn diagram. One of these supporters is chosen at random. What's the probability that this person can sing Hen Wlad Fy Nhadau? Well, there are 19 people that can sing Hen Wlad Fy Nhadau. To write it as a probability, we write it as a fraction out of the total number of people that could be chosen from, which would be 30. So there'd be 1 mark for the 19 as written as the top part of a fraction, 1 mark for the correct number on the bottom, and then 3 marks, 1 mark for putting the intersection in, 1 mark for the 5 and 6 in the right place, and 1 mark for getting them all correct. Question 3. Expand and simplify the following expression. So this isn't an equation, there's no equals or inequality in it, so we can't get a numerical answer for it. All we can do is write it in a different way. So when we're expanding the brackets, first of all, with this bracket, we're going to write x times 5x, which is 5x squared, and then we also have to multiply x by the minus 2, which will be minus 2x. With the second bracket, we have to be careful because we're multiplying in this negative number. So we've got 3 times x squared, 3x squared. The x squared is positive, the 3 is negative, signs are different, answer's negative. 3 times, so we've done that one, 3 times 2x will be 6x, minus times a minus, both signs are the same, answer is positive. 3 times 7 is 21, signs are different, answer's negative. Then we look to see what we can simplify. I can simplify the x squareds because I have 2 x squared terms. 5x squared, take away 3x squared, leaves me 2x squared. I've got a minus 2x plus 6, so I'm at minus 2 my number line, I'm going up 6, I'm going to end up at plus 4x, and then I've got this number term on its own, so we leave that where it is. So there's going to be 1 mark for multiplying out the brackets. There's going to be 1 mark for getting all the signs correct. There's going to be 1 mark for simplifying the x squared term and 1 mark for simplifying the rest. Part B, solve 22 minus f all divided by 3 equals 6. So I want to get the f on its own. So the first thing I have to get rid of is that divide by 3. To do that, I have to multiply by 3. If I multiply one side by 3, I have to multiply the other side by 3 as well. That will leave me 22 take away f on the left hand side equals 18 on the right hand side. Now what's nasty about this question is the letter that you're trying to find is negative. It's usually easier if that was positive. So what I'm going to do is I'm going to get rid of that minus f by adding f. If I add f to that side, I do the same to that side. So I'm left with 22 on the left hand side equals 18 plus f on the right hand side. I want to get the f on its own now, so I'm going to take off the 18, which leaves me f equals 4. So whether you've got 4 equals f or f equals 4, it doesn't matter, it means the same thing. Method mark for getting it down to 22 minus f equals 18. And then 1 mark would be for correctly managing the negative f. So adding f to both sides the way that I've done it. And 1 mark for your final answer, f equals 4. A fair 6-sided dice is thrown twice. What is the probability that the 3 is shown on both occasions? Now, the most common wrong mistake here is 2 out of 12. You need to be careful because when a 6-sided dice is thrown twice, that means that you've got probability 6 and probability 6. When you throw a dice once, sorry, 3, not 6. When you throw a dice once, the chances of you getting a 3 is 1 in 6. When you use the word and in probability, think about probability trees, we end up multiplying. So what you're doing is 1/6 times 1/6, which is 1 times 1 is 1, 6 6 is 36. So that's the quickest way of doing it. The other way of doing it is to consider all the possible outcomes. So I won't complete this, but just to give you a sense of it, we know that we've got 1 on the first. So if this is the first dice, second. First one could throw a 1, second one could be a 1 as well. First one could be 1, second one could be 2. 1, 3, 1, 4, 1, 5, 1, 6. Okay, so with the first dice rolling a 1, there are actually 6 combinations depending on what the second one is. And then you could do the same with a 2. 1, 2, 3, 4, 5, 6. And then the same for a 3 and a 4 and a 5. So you'd end up with 36 combinations of dice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the same for a 3 and a 4 and a 5 and a 6. 36 different combinations, and only one of them would be a double 3. But that's the quicker way of doing it, because we know that that word and means multiply. So a method mark for however you set that out, an answer mark for 1 out of 36. Company has offices in Llanelli, Carnarvon, Newtown and Ebbw Vale. Its national committee is made up of workers from these 4 offices. The pie chart shows what fraction of the committee members come from each office. So that fraction of the pie come from Llanelli, so half of the committee members come from Llanelli. There's an equal number of members from Newtown and Ebbw Vale. So that quarter has been cut into 2 equal parts. The probability that the chosen member works at Llanelli is shown in the table below, half. Carnarvon, hopefully you can see that's a quarter of a slice. And for these two, they're going to be half of a quarter. Half of a quarter is an eighth. So they'd both be an eighth. 2 marks for that. What is the probability that the member chosen as chairperson works at either Llanelli or Ebbw Vale? So when we're using the word or, think probability trees. When we're using the word or, we're adding. So with the dice question, we're multiplying. We're using the word and. With this, we are adding a half to an eighth. Okay, and there's different ways of doing fractions. You could write that as 2/8 and then end up with 3/8. Or you can use the kiss and smile method that we've been using with fractional algebra. It works exactly the same. So it's going to be 1 times 8 plus 4 times 8 over 4 times 8, which is 12 over 32, which is the same as 3 over 8. It's not asking you to simplify your fraction, so you could leave it like that if you went kiss and smile, or doing it that way. Method is for writing a quarter plus an eighth. Answer is for getting 3/8 or 12 out of 32, or any other equivalent fraction. Question 5. Calculate the value of this when I'm multiplying standard form. Hopefully you remember now. Then the easiest way of doing that is to do the 2 times 7.8-bit times 10, and then when I'm multiplying and the bases are the same, I add their powers. -4 plus 9. 2 lots of 7.8, non-calculator, do it whichever way you want. 16, 14, 15. 1 decimal point after 1 decimal point after 1 decimal point. 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 1 decimal point af the digits in the question, so there'll be 1 decimal point in the answer. So that will be 15.6 times 10 to the minus 4 plus 9 is 5. That's not going to get you full marks because this isn't in standard form. So I write that in standard form, which will be times 10 to the 1, 10 to the 0, 10 to the 1, multiplied by 10 to the power of 5. I can then add those to get 1.56 times 10 to the 6. So 1 mark if you got 15.6 times 10 to the 5, 2 marks if you then get that in the right format. Same thing here, calculate the value of 3.9 times 10 to the 8 divided by 3000. Different ways, you could work out what that is as a big number and then do a division. What I would do is turn that into standard form. Which would be 3 times 10 to the power of 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. That's the column, the place value column that the 3000 is in. Then, same as above, we're going to do 3.9 divided by 3 times 10 to the power of, and when we divide, we subtract those powers. 3.9 divided by 3 is 1.3 times 10 to the power of 5. That's between 1 and 10, so that's already in standard form. So there'll be 1 mark there for either turning the 3000 into standard form or turning the 3.9 times 10 to 8 into a number, and then 1 mark for performing the calculation. Factorize means put into brackets rather than get out of brackets. So I'm looking to see what is common to both of those terms. X is definitely there because I've got an x squared and an x, but I can also take 3 out because 3 divides into 12. 3 goes into 12 4 times. X squared divided by x leaves x. 3 divided by 3 is 1. If I take an x out, it leaves me a y, and it's a plus y. Check you're right by multiplying back. 3 times 4 is 12. X times x is x squared. I know that's right. 3x times y is 3xy, and it's a plus times a plus is a plus. So 1 mark for pulling out the right factors, and then 1 mark for the correct content to the brackets. Question 7, we haven't covered circle theorems. Question 8 is a constructions question. Line AB is drawn below. The point P lies above the line, so I'm looking for something above the line. The region in which P is located is such that P is nearer to point A than to point B. So in order to decide what makes it nearer to A, I need to have a boundary line which will be cutting that in half. So the first thing I'm going to do is bisect that line. Okay, so you need to open your compass so that it's over halfway. You don't have to measure it, it just has to be visibly over halfway. The compass point at A, draw your curve above and below the line. Then without changing the size of it, put the compass point at B and draw so that the 2 curves intersect. When I join those lines together, it is going to be exactly halfway between A and B and also at right angles. So that's your perpendicular bisector. P is nearer to A than to B, so it's on this side of that line. Angle BAP, BAP, so that means I'm drawing the angle from A. It's got to be less than or equal to 60, so I need to draw a 60-degree angle, which is the easiest of the constructions that we practiced back in the autumn. You put your compass point at A because that's where the angle is going to come from. You open out your compass. It doesn't have to be measured, Doesn't have to be over halfway or anything. It just needs to be a sort of comfortable distance. And you draw a curve. Now you know that 60 degrees is going to be up there somewhere, which means I need to have a little mark there where 60 degree will be formed. I can't put the compass point there because that's already started. So where else can I put the compass point? The only place logically is where the curve crosses the line. And that gives you that second crossing for you to draw the line. So that line is less than 60. Sorry, that line is 60. P is below that line. So it's inside that triangle now. And AP is greater than 6. So wherever P is, it's got to be, I've got to find the 6 centimeter boundary from A. To do that, we're going to draw a circle of radius 6. So I put my compass point on 0. I'm opening it out to 6 centimeters. And then put it in the center of A and drawing that second part of the circle. So, construction arcs clearly shown. That's where all these circly bits are. Shade the region in which P is located. So it's this side of that line. It's below the chapstick line and is bigger than 6. So it's greater than where my finger is pointing. So the region where P could be is in that region there. So there's 5 marks for that. 1 mark will be for constructing the perpendicular bisector. 1 mark will be for constructing the 60 degrees. 1 mark will be for the circle. 1 mark will be for shading in the correct region. And the last mark, not sure why there's 5 marks there. Possibly 2 marks for constructing the 60 degree angle. That's question 8. Question 9. So this is the OCW question. This is a tricky OCW one because you won't be comfortable writing angles and sentences like the one I'm going to draw. But the 5 marks is relatively straightforward. In the triangle ABC shown below, ABC, BAC is 40, so B to A to C is 40, and A to C to B is 80. X is a point on the side such that A to C, on AC, sorry, so there's AC, so that BX is equal to BC. So because BX is equal to BC, that means the triangle CXB is isosceles. Those two are the same. It can't be equilateral because if it was equilateral they'd all be 60 and that's 80. So because that's 80 and that's isosceles, that means that that is 80 as well. So angle BXC equals angle BCX equals 80 degrees. With an isosceles triangle, it's the angle at the bottom of the 2 equal sides that are the same. So that's why it's those two. Now you know angles in a triangle add up to 180. So angle XBC, this one, will be 180 less 160 equals 20 degrees. So I know that that is 20. prove that AX equals BX. So I want to show that that side there is the same length as that side there, which means we've got another equilateral isosceles triangle. In which case, that there is going to work out to be 40. Now, in triangle ABC, using this big triangle here, I know that that is 80 and that is 40, so I can work out what that angle there is. So that's going to be angle ABC. It will be 180 less 80 less 40, which is going to be 180 less 120, which is 60 degrees. So that whole angle there is 60, which means this angle is going to be 60 less 20, which is 40. So angle ABX will be 60 less 20 equals 40, which is the same as XAB. So therefore, hence triangle ABX must be isosceles, because that angle there is the same as that, and again it can't be equilateral because otherwise there's 60 degrees, and if that's isosceles, hence and AX equals BX. So 7 marks for that. To get the communication, you want to be writing something like that. And if you can write that, then that's brilliant. But you can get lots of marks from within it by making sure that you're putting that information in your diagram. So there'll definitely be 1 mark for working with recognizing that that's isosceles, so that's 80. You definitely have the 1 mark for then working out that that is 20. 1 mark for finding the 60. 1 mark for then showing that that's 40 degrees, and 1 mark for the conclusion. Plus the 2 marks then for how you lay that out. Even if you can't use the language, just being consistent by putting degrees after every angle will get you 1 of those 2 marks. Question 10. Grade A enlargement. All the other ones we've practiced so far, they've given you the enlargement, the two shapes, and you've got to work out what it is. This one, they're actually asking you to draw it. So enlarge the triangle below by a scale factor of minus 2, and use the origin as the center. So we're counting everything from there. And it's a negative scale factor, which means we reverse the movement from the origin to the original shape. So if we go with that corner there, in the original we're going right 1 up 2. That's going to become left 2 because we're doubling, and down 4. So left 2, down 4. So that one goes there. If I do a little circle for that one is right 3 up 2. So that's going to become left 6, down 4. Left 6, down 4. And then if I do a little square on the last one, which is right 3 up 3. That's going to become left 6, down 6. Left 6, down 6 will be there. So that's the shape that becomes. Use a pencil when you do it, just in case you go wrong. couldn't be an easier 2 marks on the paper, so long as you remember what that is. So there'd be 1 mark there for an enlargement anywhere of 2, and then the second mark would be for actually using the -2 and getting it reflected as well, rotated, sorry. Right, question 11 we can't do, question 12 we can't do. Question 13, B. I'm seeing there, sorry, we can do part A as well. A ball is thrown upwards from a height of 1 meter above the ground. After t seconds, its height above the ground is h, blah, blah, blah. Show that the time taken to reach a height of 4 meters satisfies the equation. So h is 4 equals 1 plus 8t minus 5t squared. So I've got a negative 5t squared, it's got to be positive. So I need to add 5t squared, which means I've got to add 5t squared over here. I've got a minus 8t, so I've got to take that off, which means I've got to take it off there as well. Equals 0, means I've got to take off 1, means I've got to take off 1 there. So it's just doing what we've been practicing with equations. Gives me a 5t squared on that side, minus 8t, 4 take away 1 is 3, and on this side everything's gone. 1 mark for that. To solve the equation, we need to factorize it. You should be recognizing now on the higher tier this different type of equation where we've got a squared term, a letter term, and a number only term. The way we do it is we multiply the number in front of the t squared with a number only, and I'm going to get plus 15. Okay, so then I need to list the factor pairs of 15. There aren't many. In fact, that's it. And I'm looking which pair can combine to make negative 8. Nothing I can do there, but if those were both negative, I'd get negative 8. Rewrite it, 5t squared minus 3t minus 5t plus 3 equals 0. Cover up the second pair and just work with that, looking for common factors. All I can take out is t, leaving me 5t minus 3. Check it, t times 5t, 5t squared, t times minus 3, minus 3. With the second pair then, you know you have to end up with that repeated bracket. So what can I take out of that to make that? Well, I can take 1 out. 1 times 5t is 5t, 1 times 3 is 3. But I need to make the signs the same. And at the moment, if that was positive, I'd end up with plus 5t, and I need minus 5t. So if I make that minus 1, I get minus 5t, and then minus times a minus to get the plus there. That gives me 5t minus 3, which is my repeated one, and if that comes out, the other bracket is going to be t minus 1. So if the question just asks you to factorize, that's the job. When it's solving, you've now got to work out which value of t will make this bracket go to 0. So we say either 5t minus 3 equals 0. Sometimes you can do that by inspection. You can with that one. What value of t is going to make that 0? 1. But this one's a bit messier. So we solve it as an equation. To get the t on its own, I need to add 3 to each side, giving me 5t equals 3. To get the t on its own, I have to divide by 5, and that will then give me t equals 3 over 5. Remember, in algebra we don't write divide, we put it as over. So either t is 3 over 5, or t minus 1 must equal 0, t equals 1. And then interpret your answer in the context of the question. Well, in the context of the question, what we've done is we're working to find the height, so the time it takes to reach 4. So the ball is thrown upwards. After 3.5 seconds, not 3.5, 3/5 seconds, ball passes 4 meters on way up, and then it goes beyond, so it's going from there's 4, being thrown above, and then it's coming back down. Then after 1 sec passes 4 meters on way down. I would imagine that those 2 marks for us would be quite challenging, but I would be disappointed now if you couldn't still do that. So method mark, answer mark for getting 5t minus 3t minus 1, answer mark for the 2 values. So that's question 13. Question 14. Use of the signals now. That's telling me it's a square root. That's telling me power 3. That's telling me it's positive, so no reciprocal. So that is going to be the same as the square root of 9 cubed. The square root of 9 you should know. If you don't, just go through them. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. So 3 squared is 9. Square root of 9 is 3. So that's 3 cubed, which is 3 times 3 times 3. 3 3s are 9, 9 3s 27. Second one, 10,000 to the power of minus a quarter. Reciprocal. So it's going to be 1 over. Fourth root to the power of 1. 1 over fourth root 10,000 to the power of 1. Okay, fourth root means 1 times 1 times 1 times 1 equals 1. 1 to the power of 4 is that. Fourth root of 1 is 1. 2 to the 4, 2 times 2 times 2 times 2. 2 2s are 4, 4 2s are 8, 2 8s are 16. 2 to the 4 is 16, fourth root of 16 is 2. They're interchangeable. Have a lucky guess. That's got 4 zeros after it. 10 times 10 times 10 times 10 is 10,000. So that's going to be 1 over 10 to the power of 1. Anything to the power of 1 is just itself. So you're looking for that. We've practiced plenty of those. They're coming up every time. It's worth getting your head around that. And then the final question that we can do on this paper is question 15. Repeated recurring decimal. Let x equals the repeat 2, 4, 5, 4, 5, 4, 5. We need to then multiply it by 10, 100, 1,000 to get just the repeated part. So if I multiply it by 10, I get 2.454545. If I took those away, it wouldn't get rid of the repeated part because I'd be doing 4 take away 2. So I need to multiplied again to get the next point where I've got 4545. If I multiplied it by 100, I get 24.54, not 45. So that wouldn't cancel it. So I need to multiply it by 1,000, which would then give me 245.454545. Subtract 1,000 take away 10 is 990. 245 take away 2 is 243. All the decimals go. X would be 243 out of 990. 1 mark for the method of eliminating the decimal, 1 mark for turning it into a fraction. and then our old friend the surd in a double bracket. First, 5 times 8, 40. Outer, 8 times root 7, positive, positive, positive. Inside, 5 times 3, 15 root 7, negative times a plus, signs are different, answer's negative. And then finally, 3 root 7 times root 7, negative times a positive, signs are different, answer's negative. Then we can simplify that a little bit. I've got 40, I'll leave it there. 8 root 7 take away 15 root 7 is the same as thinking about 8x take away 15x. 8x take away 15x is minus 7x. So that would be the same as minus 7 root 7. And then here you've got 3 times root 7 times itself, just becomes 7. 21. 40 take away 21 is 19, take away 7 root 7. 1 mark for correctly expanding the bracket, 1 mark for doing all your simplifying. And that is it. So on that paper we had 47 marks available to us. Got all of those right, and you would comfortably be in the grade A zone. So that's it for as far as Unit 1 papers. The next ones that I'll start uploading over the next week and into half term now will be Unit 2 calculator allowed.